Okay, so we're in programming day number 2. So we are going to do 2 programs today. We, meaning I, will do most of the work on the first one. We, meaning you, will do all of the work on the second one. So I'm going to do an SAA program with you, with your guidance and my guidance together. We'll work this out. I would encourage you to just write down everything that's on the board. And then when you leave this place, you're going to try to write yourself for homework an ASA program, which will be very similar to what we're doing. So if you actually understand what we're doing, you should be just fine to write the other one yourself. If you don't understand what we're doing, you need to ask questions and get that figured out in the next half hour or so. So if I want to draw you an SAA triangle out of items 1, 2, 3, 4, 5, and 6, can you give me a trio of items that, if they were known, would make this be an SAA triangle?
1, 2, 4.
Agree with 1, 2, 4, because that's a side. And then there's 2 angles that are not the 2 angles that included it. If I gave you these 3 pieces, 1, 2, 6, what kind of triangle would that be?
ASA.
That would be an ASA triangle because the angles include the side. Other than 1, 2, 4, can somebody else, different person, give me a trio that would give me an SAA type triangle?
3, 6, 2.
3, 6, 2, I agree. 3, 2, and 6, that would be an SAA kind of triangle. I'm going to just quickly mark these because those are the ones that we said first. But if we knew these 3 numbers, that would be an SAA picture. That's the kind of thing we're trying to do. Last time we wrote a program, we had a conversation about who talks to whom first. Machine talk first, person talk first. Machine talks first. How did the machine talk to you? There was a command called display. In terms of punctuation, do you remember punctuation? Quotation marks. And we're going to have to ask for one of these 3 items. Which one of those items is the easiest one to ask for?
The third angle.
Probably not. The side. Why is it easier if we're trying to acquire the 3 dots? Why is it easier to ask for the side? If I say enter the side, why is that less confusing? There's only one of those. So I'd start off asking for the side. And then the machine wants to receive it. What was the command that does that part of it?
Input.
Input. And then we need to give that a name. Last time we had A's, B's, and C's. What do you want to call this? Because you guys are bored. I might have said S for side or something else, but it doesn't really matter. We just need that to have a name for the duration of the next 20 minutes. That side is just going to be called A because we said so. Then, what would happen next?
She's going to ask you for another thing.
Yeah, we're going to need to ask for another thing, so that's another display. Can somebody think of a way we could ask for another thing? What do we need to ask for?
An angle.
Okay. Does it matter which one we ask for?
No.
I would say yes.
The one across from the A.
Yeah, because we need to maintain some sort of knowledge of relationship. What am I talking about, that there's a relationship? Number 1 or number 2, which one has a relationship?
2.
2. What relationship does 2 have? Who does 2 have a relationship to?
A.
2. How are 2 and A related? What's it called?
They're opposites.
They're opposites. So we can't just say just give me any old other angle. it's important for us to maintain a knowledge of who is opposite who, because that matters. These aren't just random angles. So something like enter the, what was the magic word? Opposite angle. And I try to shorten my sentences down as much as I can, because you've probably noticed your display isn't this big this way. Your display is also not that big this way. So if you ask some sort of big, giant, extravagant sentence, you're going to fill the screen really quick and just run out of room. So you want to be a little bit conservative about how much language is in your sentences. Good foot. And then that needs a name.
B.
B. So for the next however many minutes, that's going to be known as B in anything that we do. Then,
Display.
display. Now what do we need?
Enter the third angle.
Yeah, we need that other
Angle.
angle. And then,
Input.
and that needs a name.
C.
All of the programs pretty much start off that way. Display, input, display, input, display, input. These are called prompts. Sometimes in computer terms, these are called a prompt. So you're prompted for some information, and then it takes it in. Then it's time to do math. Okay, so after we get the information gathered, it's math time. So if we think about this triangle, and we use our imagination, that these circle things are known numbers. Okay. Any triangle we did of this format, we've always gotten the next fact the same way. What next fact would you get out of 1, 2, and 3? Who would you figure out next if these were known? 3. How would you make that? How would you figure that out?
180 minus 60.
Do 180 minus stuff. Is this going to need to get reused later to do more answers?
Yes.
Yes. So it's going to need a name. So let's call this
D.
D. D is going to lead us to who?
1.
To number 1. Okay. This is going to lead us to this eventually. What math did you just say you were going to do?
180 minus C plus B.
If we do that, we have a problem. We need parentheses around C plus B. Or, if we want to take a little algebra move, what can we do with that minus sign? Think algebra 1. Make this like it's a tad shorter.
Change both sides.
Yeah, the minus, we could, what's it called that you just did there? Distribute. You could distribute that minus sign in through there and get something like that. Either way is fine, it's not crucial. Then there's a button we've never used before that's a store button on the calculator. I think it's toward the bottom left-ish. I think it's on the left margin, like a lot of the way down. It says STO on it. Is that where that is? So we're going to use the store button to give this the name B. Okay, if it's something that was previously known, input sucks that in from a person who previously knew it. But when the calculator does math and figures things out for you, we're going to want to store those in a new location.
Where was it?
It's toward the bottom left. It's definitely along the left,
It's next to the 1.
next to the 1.
Oh.
See it? So that'll store stuff for later. So we know an answer. What should happen?
We should get another answer.
Before we get another answer, what should we do? Yeah, say what the answer is. How are we going to have it say what the answer is?
Display.
Display. But I wouldn't go as vague as answer is. I would try to be a little bit descriptive of what we just found. What did we just find?
Angle D.
The angle. So something like angle is. And then another display, and we called that what's the name of it now?
D.
D. You could also use the answer button because it is the most recent answer that we would have had math compute for us, but we could either do answer button or D. Question about that? Then what?
Solve for something else.
Yeah, go figure out something else. So this is like my scratch work area over here. This isn't part of your program. This is just our conversational area. So where did we decide D was going to lead us?
The 1.
To the 1. So we'll give this a name for our purposes.
E.
E works. So how would you set up something that could solve for E? I'll circle the things as they're becoming known.
A over sine B equals E over sine D.
That works. Okay, so we could do law of sines. E over sine D equals A over sine B. To solve this for E, this would have to go up with A. So we would go A sine D, and the calculator will force this on you, so you have to wrap that up. Divide by sine B. I don't think it matters if you wrap that up because you're at the end of the line. It can't hurt to do it, but I don't think you need to. So now we know another answer. And what should we say? What should we do?
Display.
Another display.
Side E is.
I wouldn't refer to it as side E because the person who's using this has no idea what we chose as our lettering system. So that only means something, the A, B, C, D, E only means something to us right now while we can see it. But a person using this, all they know is what they entered, what they just got. How can we refer to this E side in a way that makes sense to the person later?
Other side is.
But there's two other sides.
Side opposite D.
Yeah, so something like angle is 30. So that has our attention here. So I could say to you, I'm going to draw this triangle. I could say to you, like, I have an angle of 30. How would I get your attention over there?
Opposite side.
Yeah. So something like angle is 30 with opposite side. And now you know where to put it. And this would be display.
E.
There'd be a problem right now with display E. Why would we have a problem right now with display E?
Because the computer doesn't know what the E is.
Yeah, I didn't name it E in here. So I could either name it E in here or we could work around that. It doesn't really matter.
That's my answer.
We could just go display answer. Why wasn't I as insistent on storing the E as I was insistent on storing the D?
Because we needed the D for
Say it louder.
We needed the D for the law sign.
Yeah, we needed the D to get ourselves E. Do we need E to get this thing that's right now called 2? No. Could we use E to get number 2? Yeah, but we don't need it because we can get 2 from C and B and A. We don't need this to have a name. Could it have a name?
Yeah.
Sure. But it doesn't need a name. So if you want to name that E and do display E, there's nothing wrong with that. But we don't need to, so I don't feel like doing that. Then it's time for us to try to get this thing that I called number 2. For our little scratch work area, I'm supposing you'll want to call that F, because that's just the way that that's going. So F over
Sine C
C,
equals A over sine B.
the same thing, just repeat it again. That's gonna scoot up again the same way. So we have A sine C, divide by sine B. Again, these parentheses, I don't think you need them, but they don't hurt. Do we need to store that? No, because we're basically done. Could you store it? Sure. Then come back with
Display.
display. Some words to just describe what it is you found. You just found,
The leading side.
yeah, the last side, something like that. And the other one you do, you can choose your own wording. My exact wording isn't important. Again, I'm just trying to go short. I'm just trying to, issue could be, if this sentence was super long and took up a couple lines, and then you had an answer, and this is super long, couple lines, and then an answer, and then a couple more lines, and then an answer, you don't have that many lines. And how quickly does this program go? Like your quadratic, how long did it take?
The program or to get the answer?
To run it, when you actually go to run it. How long does it take to give you the answer back?
Like 2 seconds.
Yeah, not even, like a millisecond, it's like boom. So if your screen can only fit like 6 or 8 lines, and you make these sentences too long, this would, what would happen to the beginning part if your sentences were super long? If it shot all of this back to you in a millisecond, and these were long sentences, do you see a problem that would ensue? Let me borrow a calculator for a second. So we have on the display 1, 2, 3, 4. We can only fit 8 lines. 8 lines of facts can fit on your screen at a time. So if this took a couple lines of a sentence with an answer, and that took a couple lines of sentence with a line of answer, and this took a couple lines of sentence with a line of answer, and you had like 12 lines, and your screen can only fit 8. Why would that be a problem to you?
You can't see everything you need to put in.
Yeah, you can't see it. Like, how long does it take to display on your screen?
A millisecond.
Like a millisecond. How long does it take you to read a sentence?
Forever.
For between a couple seconds and forever. Depends on your reading ability, right? But if this shot out these sentences and these answers, and you had too much space to fill, if you had 12 lines worth of facts to fit in 8 lines of space, the top would like disappear off your screen. So it is kind of important to keep these sentences shorter, just so that everything can fit. What are we left here to do?
Display answer.
Display answer. And that'll do it. There's no weird things in this. There's no like ifs or go-tos or anything crazy. Most of the programs will run this basic way. Ask for something and get it, ask for something else and get it, ask for something else and get it. Sometimes you need your sentences to be kind of specific to maintain relationships. Like B was the opposite of A, we need to maintain our knowledge of that relationship. But some of the programs you don't, like the SSS program. Does it matter what order you would enter the sides or what order you start? No, you just say something, you could say at the beginning something like enter, even stronger than that.
Any side? Any side?
Even better than that.
Left side.
How many sides you gonna do?
3.
Do they matter what order you do them in?
No.
No, so just tell the person, enter
Side.
3 sides.
Oh.
Just have one command that they'll enter all 3 things. You could do that. It saves you some space this way. Just say, have one display to say enter 3 sides, and then you follow that with input, then input B, input C. This program, you can't do that though. This program, you have to be a little careful what you ask for. We have one side, so let's get it. Then let's preserve relationship knowledge and get the opposite side, or the opposite angle. Then let's get another angle. But you'll usually go display, input, display, input, display, input. But sometimes you can shrink that if it's more, if there's less relationship among the items. And then start doing some math. Do some math, and then usually a double display. One sentence to title what you got, and then another just, here's the number for it. Do some more math. A descriptive sentence, and then and a number. More math, descriptive sentence, number. That's kind of the way to go. Let's take a step back here and minor preview ya. So 1, 2, 3, 4, 5, 6. What was a trio that you said could be an ASA?
1, 2, 5.
1, 2, 5. What do you think you'd ask for first? Probably the side, because there's only, there's one. It's easier to ask for that, so just get that out of the way. When we go to ask for the angles, do we have to, like, maintain some kind of knowledge of relationship, or is it enough for just to randomly ask for any of them? You could randomly just ask for anything. So we don't have to be as choosy about our sentences here, but you would want to get an angle and you would want to get another angle. Once these are known, would you do a 180 thing to get that figured out? Yeah. So the math on this would look pretty much same kind of thing. When you go to get a side, would you use the law of signs to get a side? Once we know all of those, law of signs to get a side, so you'll have math that looks very similar to this. Would you do more law of signs to get the other side?
Yes.
So the basic structure of the one you're doing is about the same as mine. You're just going to have to change like which letters are which. You're not going to be able to just steal all the same letters in all the same order. That's not going to work out because if you call this A and this B and this C, well, we just lost some of our relationship. Like A in this picture goes with B. But here, if you go A, B, C again in that order, A doesn't go with B. A goes with whatever you call that. E, F, G, whatever letter that is. So in terms of style of how these look, yes, it's going to be the same. But don't just punch into the one you're doing yourself, A sine D divide sine B. That's not a thing anymore. You're going to have your own little scratch work zone where you're deciding who's with who, your own little law signs kind of scratch work zone to write this program. I would not encourage you to just sit down and look at the screen and compose it. I would strongly encourage you to try to do it in written form and then type it in. Because if you start to just try to look at the screen and do it all in your mind, I think you're going to like lose your place of what you're thinking. So somewhere you should have a paper version of this. Another great reason to have a paper version of this is sometimes batteries die. Sometimes things get deleted by accident. Sometimes weird things happen. You've probably had an experience like that in your life with a computer. You thought you had it saved, but you didn't. And if you don't have the paper version, life just got harder than if you had a paper version and you're like, well, that stinks, it got erased, I'll just type it back in. Instead of, oh, that stinks, it got erased. How did I even do that? Am I gonna have to queue up that YouTube video again? Do it, it's a drag. So written version is highly recommended. Question? Let's get you started with the buttons again, just while you're here in the room, and we can make sure we get this off to a good start. So how do we begin the process of getting this stuff entered? Program button. And then you had to give it a name. It has the flashy cursor flashing at you with the alphabet button on it. What do you think a good name for this would be?
SAA.
I would say SAA is a pretty good name for this. So you go SAA, you hit enter. How did you get the display button? Program. And it's in the IO list. Grab that. How do you do 1,000,000 letters in a row, which includes the quote marks as a letter because they're in green?
Second alpha.
Second alpha. So second alpha locks the alphabet on, and then we go, go, go. I don't think there's any other fancy buttons on here. It's just displays, inputs, answers, basic maths. It's not too much. When you want to save and get out,
Second,
second, and then,
the one next to it.
I'm not sure, what's it say in yellow?
Quit.
Quit is correct, it's absolutely quit, yes. So second quit, like Sage, and gets out. Question before we turn you loose and cut the video. So homework is twofold, threefold. A, type this in. B, create another program to do ASA, type that in. C, find a triangle in the real world and then test it. So you could go to the 28 triangles. Okay, the 28 triangle homework page had an SAA section. The 28 triangle page had an ASA section. Go to that page of the book and pick one of each and just test it out. Or if your sheet is handier, the sheet with all the triangles on it that we did the other day, that has one of each type on it too. So you could leaf through that and just find an SAA or an ASA and like try that out. But get them both, get one typed in, get the other one typed in, and then test them out. And tomorrow we'll do a similar thing. We, mostly me, will write one, and then we, entirely you, will write another similar one, and that's tomorrow's day.
Where's the display button at?
You hit program, and then it's in the I/O list. You see it? That's it.